All right. So today, guys, today we have chapter 4. Again, those that make lots of money do a lot of optimization. Airline scheduling, any transport scheduling. Airlines especially hard because you need to make all the planes reset and start off where they began eventually. Lots of people want to go to Chicago. Not many people want to go to Sheboygan. It's difficult to figure out how do you get those that need to go to Sheboygan, but still let Chicago people be where they want to be. And then scheduling cruise and FAA regulations, and if there's any weather delays, sorry, that crew that couldn't even take off, you are now off duty because you've been on shift for too long. And then they need to find a new shift of people to get on the plane where it's stranded. Good times. The roommate that does that, she makes 5 or 6 times my salary. And as much as we complain, MCPS teachers, we're not poor. Anyway, all right, so today, in this thing, identifying local and absolute maximums and minimums. Okay, do you guys know what the vocabulary means? What's the local maximum, Max?
Do you want me to like the point or like?
This is part of the question. What does my vocabulary mean? What is the local maximum?
The local maximum is any point where it's
on this
one. Okay. Negative 2.7, 2.1, so 2.1. Or yes, that's the y coordinate. Sorry.
So he gave a lot of information, but in the end he said the local maximum is 2.1. And he kind of threw in there at negative 2.7, but what is the maximum? What is the high temperature? The high temperature is 2.1. When did it happen at negative 2.7? Okay, so the temperature analogy is not working with the negative numbers, but so what's the local minimum? Will?
Negative 3.25 at x equals 1%.
So you don't need to necessarily say where, but the minimum, negative 3.45. The maximum, 2.1. And they're local. Local means I'm standing up here on the hill, I look left, I look right, I'm a big man on campus. Local minimum, I'm standing down here, look left, look right, I'm shorter than everybody. Okay, absolute maximum. In pre-cal last year, first period said, no, man, we didn't do that. What is the absolute maximum? Emmett?
The highest point on the entire graph.
Okay, where is it?
There is one.
So, y'all don't write checks anymore, but I used to say, like, the absolute maximum, they want you to actually be able to write a number down on a check to give somebody. So if you were gonna Venmo somebody, you can't Venmo infinity. You had to pick a number so that the machine could go, okay, send over this much. If it's going to positive or negative infinity, we don't want you to say there's a maximum. I want a number, I don't want a moving target. Cool? It's not like the national debt, that is a forever moving larger and larger number. Okay, so today we're just going to talk about how to find the extreme values of functions and the vocabulary of absolute, global, they mean the same thing. Absolute is biggest of the big or smallest of the small, same with global. And we will talk about local and relative. Local is just right here, relative also means just right here. If you're a local maximum, can you also be the global maximum?
Yes.
Yes. Katie Ledecky, love her. She's a local swimmer. She's kind of fast. Oh wait, she's got the Olympic record as well. She's globally the fastest as well. So, all right. Your textbook can make math as difficult as possible. Here they're defining what it means to be an absolute maximum. F of C, that's the y value of some function. It's the absolute maximum if over the entire domain, it's bigger than or equal to all the other y values. Can we have more than one maximum? People are saying no. Okay,
Well, if you have one's going to infinity, one's going to,
infinity is not an absolute maximum.
so no.
Couldn't you, if it touches it twice, it would be at two different places, but it would be the same? Yeah.
Sine curve. What's the highest y value on a sine curve? How many times does it hit one? A whole crap ton, like an infinite number of them. So yeah, you can have a whole bunch of those maximums, and they're all gonna be the same y value, but it can be in more than one place. Pi over 2, 5 pi over 2, and 9 pi over 2, like all of those. So now their math definition of minimum. It's the y value that the lowest of all the other y values, lowest or equal to the lowest. Okay, with that, Zach? Right. What high? What, yeah.
Do you have to say like the x point that it's at?
So,
Like for that example, you would,
goodness, so be very careful. If I said, what's the maximum of sine, that's easy, that's 1. If I say, tell me all of them.
okay.
Like, if I say where, that one's the x value. If I say what is the high, I want the y value. And sometimes where is easier and sometimes what is easier.
If you're given a graph, just like ends, then it's not that.
Well, they're not gonna ever
Yeah.
do anything easy for you. Welcome to calculus. Sorry. Okay, so we're gonna have lots of pictures that look exactly the same. And this parabola, infinity to negative to the whatever domain, all of them. Zach, over there, Zach. Okay, what is the absolute maximum?
There is no.
There is none, because goes to infinity, so no max. What's the minimum? Nadia, what's the minimum? 0. Jacob, where does the minimum happen?
That's 0.
At x equals 0. So the absolute minimum is y equals 0, and unfortunately the absolute max happens at 0 as well. Charian, how about this one? I've cut the domain, it's now 0 to 2. What's the maximum?
4.
4. Ben, where does the maximum happen?
X equals 2.
At 2. And the absolute minimum is still 0. Where does it happen? At x equals 0. Okay, Ella, how about this? Is a open, is a closed. What's the maximum? The maximum would still be 4. So what's the minimum?
0.000 forever.
Okay, you can't say 0.00 forever. So first period we got really childish. I had someone like, look, there's 0, 1. I'm like, oh yeah, well I'm gonna step in between those zeros and I'm gonna put in a googleplex more zeros, 0.001, and then he's like, oh yeah, well I'm gonna get in there and I'm gonna put in another googleplex of zeros, so you know, I can be childish. I teach high school, I have been trained. No minimum. Because I want a number that you can write down on a check or Venmo. Venmo. But you need to type in a number. And no numbers with hats, no 0.1 repeating. Yep.
In the previous example, you said that the absolute maximum and minimum of both is 0? Or whether
No.
maximum?
The previous example.
No, the one before that.
One before that.
Previous.
This one?
Yeah, there's no max.
Yep. Woo. Okay. Okay, Martha, what do you think? Is an open circle is an open circle? No max. No min.
It's a upside down smiley.
It's an upside down smiley face. I should probably erase that. Those have meanings. Okay. This might be the first thing you need to write down. Extreme value theorem. Extreme value theorem. The function's continuous over closed intervals. And I get a notebook out. So, extreme value theorem says continuous over closed interval. So everyone in the class, we're all in a race. And you have to participate. So maybe the race goes off and, you know, someone in the middle had the fastest time and then someone towards the end had the slowest time and then there were the two people in the end, they were just somewhere in the middle. But no matter what, in that closed interval of that function, someone had to be fastest and someone had to be slowest. Closed interval, continuous, has to happen. And it could be the fastest and the slowest, or maybe I lined everybody up by height, and gee, the tallest person was on one end, and the smallest person, probably me, is on the other end. Or maybe the high was in the middle, and the low point was on the end, or maybe the low point was in the middle, and the high point was on the end. Point is, check your ends. All right. No one else writing more quotes on the thing that I wrote. So, extreme value theorem, continuous over a closed interval, you are guaranteed a max, you are guaranteed a min. And they will ask you this in tricky ways on multiple choice. Right, Jerry? Mm-hmm. Don't draw it, this is in your textbook, but I want you to notice, what's the slope right there where I hit a maximum? What's this slope? Undefined. So, to find a maximum or a minimum,
Slope is not the 0 or the
the slope will be 0 or undefined. And okay, so right here, I drew a 0 slope. Does that mean that this was a max or a min? No, but in order to have a max, I had to hit 0, or I maybe had to hit an undefined. So you can't have a max or a min unless the first derivative was 0 or defined. So, oops. You need to know what a critical point is. Wow, the board's bizarre. Now it's ombre for you all. You write that down. Definition of critical point. Critical point is where the first derivative is 0 or undefined. Try and find the critical points for the problem that's up there. right here, did you do, quotient rule? No, okay. Those of you who are tempted to do quotient rule because there's a denominator, that denominator is just a number. So really, that second thing, you're just doing the derivative of x squared and multiplying by the number out front. Okay, critical point. Where is it undefined? Esther, where is f prime undefined?
That's always.
When is it undefined? When am I dividing by 0 or doing a square root of a negative? Never. Now, where is it 0? Sebastian, how do I find where it's 0?
You could factor.
So, how do I factor? I don't do that.
You don't do that.
No. So, you have to do it.
Oh, okay. Alright, so you could do, like, maybe 1 second, can you write that out real quick?
See, y'all,
Alright, so
I'm
we
from
got,
Delaware. We do this in different ways.
Alright, so we have,
Yeah, that's it.
oh, yeah, you did that differently, right?
Yeah. 2x.
Plus 3 times x minus 2. You got the answer.
So let's just check 2x squared. Checking this part. Minus 4x plus 3x gives me that negative x. And that's a negative 6, so yeah, it works. So I factor by Zen. It's high school. Generally, they're going to be nice to you. So 2 things that multiply to be 2x squared, that's nice. 2x and x. All right, this one's a little bit harder. 2 things that multiply to be 6. Could be 6 and 1, could be 3 and 2. Kind of thinking for it to subtract to be 1, it's not going to be that 6. And if it was going to be 3 and 2, the 2 doesn't go here because 2 would have factored out everybody. Okay, so Zen takes a little logic. But 2 and 3, and yeah, okay, that's not working for y'all. I learned to factor by Zen in 4th grade. Delaware was a weird place.
That's young.
Yeah. The whole state was owned by DuPont, so they wanted engineers that lived there because they had to keep importing them, and that was expensive. So where are the critical points? At -3, x equals -3/2, and x equals +2. In pre-cal last year, I know because I'm teaching it now, we made you do all these things with rational functions. Find all the zeros, find the domain, find the x and y intercepts, find the asymptotes. Well, I can tell you that from algebra 2, it's going to be some kind of wiggle like this. And now with calculus, I can tell you this local maximum up bubble is going to happen at x equals -3/2. And this minimum, local minimum, is going to happen at x equals +2. At,
So it's, when they're asking for the critical points, they're just asking for the x value?
yes.
Okay.
So, Brooke, this is where they might say, just tell me where the maxes and mins happen. They're just asking you to find the critical points.
Okay.
If they then say, and now find the blah, you're gonna have to find blah. Yeah.
And you just kind of use that by knowing like the shapes, like how they look.
Yeah.
And then getting x points, and you can just like put them up how you would see them.
Okay, so, as because of the calculus, we're gonna start to put together lots of stuff. Like, you should know some of these things from algebra 2. The lead power was an x cubed, so it's gonna be an odd function that's gonna do something like that. That it's cubed, or to the 5th, or to the 7th. It's probably gonna have some wiggles. And that the front number was positive, it's gonna go from low to high. Ileana?
Well, just, I was gonna ask, how do you know which one's the max and which one's the min? But
Because this was positive, and it's gonna do like every cubic I've ever seen that has a positive front, which is a cubic y equals x cubed is just that. Okay, this one had a max and a min, so there's a bubble up and a bubble down. So we're gonna start putting it together that you can do lots of all the things about the graph without a graph. Okay. X cubed. Do I have any critical points? How do I find critical points, Nico?
Critical points?
Uh-huh. Where the first derivative is zero undefined, so what do I have to do?
You set
I don't have a derivative.
you find the derivative
Oh.
is 3x squared.
Okay.
Like that, you can keep doing something else.
Okay, and I will ask this a lot and you'll look at me like I'm stupid, but where is it undefined? It isn't, but you need to know that critical points are also where it's undefined. And, cause we're getting you used to the idea, so in the beginning, everything's a polynomial, it's all nice and pretty. And you need to remember there are places that might not be defined. So it's not undefined anywhere, but actually, where is it? Zero. Okay? So critical point, first derivative is zero at zero. Right there. Plugging into the first derivative like negative 900, got squared, so it's positive. And then after on the other side of zero, it's still positive. So that's, you were driving along, you came to the stop sign, stopped, and then you went forward. Not a critical point. It's not a max, it's not a min. Because looking one side, haha, I am bigger than all those before me. And looking this way, oh, poop, I'm down here. So it's not a max or a min. Physics friends, what is it?
Inflection point.
Inflection point? Yeah. In other contexts, have you heard of the inflection point? Like, it's in the news all the time. It was the inflection point in the conflict. It was the inflection point in the war. It's where the tide started to change. It's when the concavity stops going that way and starts going the other way. It's either starting to get better and better for you or starting to get worse and worse. Okay. Alice, how do I do this thing? Y equals x to the 1/3. Finding critical points, what I do? So what is the derivative of this? Okay, multiply by the power, lower the power. So Megan, where is it undefined? Undefined at x equals 0. Where is it 0? Nowhere. Vertical asymptote, sorry, what? You said something. Oh, okay. This one, again, checking our first derivative. It was positive, positive. Didn't change sign, doesn't matter, but, so it's not a max, it's not a min, but it is a critical point. Yeah? Good test. The y value changes sign in the function. The first derivative is positive the whole way. Everything is positive, slope, happy, cheery, woohoo, it's all up from here ever so slowly, but it's up. Okay, too many words, I meant to take some of these off. Okay. So, guys, in tonight's homework, which I recommend you do, hopefully it will be easy. And doing it will help you avoid mistakes on the quiz and the test. First thing, identify the domain that you're working with. Hold. Next, find the critical points. So find the critical points. All those words. Find the domain, establish that. Find your critical points. The stuff I scratched out is, only take the critical points that are in the domain you're talking about. If you're like, oh my goodness, everything's happening from time 1 to 2, and you find your critical points at negative 18 and 5,000, we don't care. Okay. Next thing, we're going to do this guy. Make a T-chart. Put the endpoints there and each critical point. And go back to the function, not the derivative, and find those y values. We're gonna do an example, so this will make more sense in a second. But, Coleman, pick a number.
5.
Ben, pick a number. Cherry, pick a number.
40.
Eliana, pick a negative number.
-3.
-3. Kaylee, pick a number.
-1.
Negative what?
Oh, do you want to do negative?
Oh, I don't care, you're.
Oh, -7.
-7. Okay, so if I have a continuous function, and these things were all my critical points, and now I'm like, ooh, what's the absolute maximum? What is it?
46.
You look in the little table of y's and, oh, the biggest one is right there. What's the absolute minimum in this spectrum of stuff? The -7. So somebody in the first period was like, I didn't see step 4. I'm like, well, it's just saying, look at the list and what's the big number? Look at the list and see what's the little number. That's all. It's not like. Okay, I want to know, is it possible to have another high or low, no, pick a number. Pick a simple number, -10 to 10.
A simple number, okay, 8.
8. Oh, so close. So 8 is one of my critical points. Logan, pick another number between -10 and 10.
-8.
-8. Okay, very creative. These are my critical points. And my endpoints, -10 and 10. If these are my critical points, is it possible, could I have another maximum or minimum in between those guys?
No.
Why not?
Critical point.
I would have had to find other critical points. So,
Maximum and minimum have to be critical points, don't have to be maximum.
okay, what he said, to be a max or min, it has to happen at a critical point. However, not all critical points are maxes and mins. Yeah. All squares are rectangles, not all rectangles are squares. But, like, yes, a square is a rectangle, they all have right angles.
You say that again. You say that again.
All squares are rectangles,
No, no.
all rectangles are not squares. Okay, the point of this, if I find all the critical points, I can't have, like, hiding between these, I couldn't have, like, suddenly had a y value higher.
Oh, yeah.
And in between these, there can't be some stealthy, like, ha-ha, let's go, it went lower and then came back up. Because I would have had to have some critical point. Yeah,
So you're just saying that in between the critical points, it can't go higher or lower than where it's already set?
it's got, yeah.
It's like horizontal, but it's
Okay.
not, but it's like it.
So in between the critical points, not a fun word, but it's monotonic, like monotone. It's doing the same thing. If it was going up, it's gonna stay going up the whole time. And if it was going down, it's gonna stay going down the whole time until it hits that next critical point. Okay. So, here is a problem for you to try. Find the absolute max and min. Okay, so did you just do the problem? Yes. Who also had a sibling that is also on the wall? Matt Iceland or Josh Iceland. They're the last ones though. Do any of you have siblings on the wall? And Taylor's not on the wall.
Yeah. You're gonna be.
Genevieve's on the
Is he
wall,
gonna
she's
get
on
on
the
the wall
wall,
first, second wall?
behind you. Okay. None of you, not last year, but. Did you already stick her name?
You can my chair right now.
Did you tell him? Did you take a picture and like
That makes equal zero.
I told him when I said it.
But the middle of the maximum of like
What did I find?
I think you found a critical point. I don't think so.
Not all critical points.
I don't think there are.
You just plug in -1. So we don't even ask.
Yeah, so you plug in, you get the.
Okay, first step was establish the domain. What did they tell us the domain was? -1 to not infinity.
I thought it was.
Okay. Establish the domain. There it is. And way I'm going to establish it, I'm gonna make that T-chart right away. And then this is a me thing, not a. Oh, thanks. All right. So, finding the absolute max and absolute min. I'm gonna circle this one. Why am I circling it? What's weird with the domain? 8 is not included in the domain. Just like when we did limits though, sometimes we would actually plug in the value, or in piecewise functions, it said, as we get close to 1 but not including 1, I'm gonna put that number in there anyway. Just for grins and giggles. All right, so then the next thing, we see we had to do what?
Like fill in the X and Y values, the X with the critical points.
I have to find the critical points. How do I do that?
Set the slope equals 0 or where it's undefined.
So what is the slope?
2 over the cube root of X.
So the critical point, I have one critical point, which is 0. So, Emmett, what do I do with that now? I put them in my T-chart, so I establish the domain, I find the critical points, I put things in a table. How do I fill out the other side of the table?
Plug it back to the original function.
The original function, not the derivative?
The original function.
The original function, I agree with you. So plugging in -1, what's -1 to the 2/3? Positive 1 or negative? Positive. Plugging 0 in, what's 0 to the 2/3? 0. Common, plugging in 8.
You got 4?
You get 4. How'd you do that?
I did, the cube root of 8 and then square.
Perfect. So cubed root first, he made the number smaller. Cubed root of 8 is 2, 2 squared is 4. So, what is the absolute maximum? What's the absolute maximum? Doesn't exist.
Oh, so if it's the highest point, but it's an open circle.
So, the function was going along, it would have been at x equals 8 if I was able to get there. But it's an open circle, so I gotta be like, I know it's not gonna go higher than this, but that's done. So no absolute max. And believe it or not, from pre-cal last year, power functions unit, which is the stupidest thing ever invented, that we had to start teaching 4 years ago, you should be able to know that that's what that function's gonna look like. Yet, Sebastian, I know because I teach it every year now, for 4 years, I'm like, this is dumb. But when I get to here, I'm like, oh, I know why. Yay. All right, sorry. So what's the, sorry, Abigail.
Why don't we need to make a sign chart?
Okay, you can. Is it gonna tell you which y value is bigger or smaller? You just know that it's going to be increasing or that it's going to be decreasing. You don't know what the y's specific value is. So if I'm asking you, what is the highest y, you're gonna eventually need to plug it in. So we're gonna end up doing both, doing a number line of, all right, let's check the first derivative. at its one critical point, putting in a negative number, I get a negative number, putting in a positive number, I get a positive number. So I know there's gonna be a minimum at 0, and I know it's gonna be the absolute by looking at that, but I can't tell about the maximum.
Wait, so what does that tell you? That it's a minimum or maximum? If you get negative, positive, or positive, negative?
All right? First derivative was forever going down till that critical point, and then it was forever going up. In the entire domain they asked me about, but also infinity, negative infinity, or infinity, I know that this is gonna be an absolute min.
Okay.
But Abigail, I only know where it's gonna happen by looking at this. I need to plug it into the original function, as Emmett said, to get the actual minimum. Y equals 1, like looking in the chart, is that an absolute max, an absolute min, local max, local min? What is it? Local max, besides looking at the graph that I drew, why?
It's the only max that we can put.
Okay, I see it as, well, from the end point, I started at 1 and I went down to 0. So he's the high one. And then I hit 0 and then I went up to 4. Okay. So here, he was highest, because everything went downhill from there. And boop, bounced at 0. Okay. Really large. Okay, find the absolute maximums on these. Aiden's volunteering to put the problem up. And Ben will help him.
Thank you. Thank you so much.
I gave Howard. Yeah. Are you ready with the back?
Did you have to remember the back?
Do you have another pen?
No, but you can write with your finger. No, you can, look, you can both write at the same time.
How do you erase it? I don't like it.
No, it doesn't do that.
Can we make it excellent?
Yeah, you did that.
Alright, word.
Two over three. Then let's put those in, so we get -1, -1, plus 4, 2, so that's 5 for that, 57 minus.
Okay, so we need some help with, you can use a calculator to find the value.
So 25.
Well, quadratic formula, you don't need quadratic formula, you can solve for the critical points. Set it to 0.
You plug one, I'll plug the negative, you plug the positive. Wait, where is it?
It's a yes decimal. I don't remember what it is though.
Can you solve them for us?
Ashley's got it.
Alright, what's?
Samara's working on it. Alice has got it cooking. Okay, so find the first derivative. Find the critical points, which is, where is it undefined? Nowhere. Where is it 0? Plus or minus the square root of 2/3. So then Ben put them on the table and put the critical points, -1 to 3. Even did my thing of circling the 3. Why did he circle the 3? Because it's not included in the domain. So we get a number of y value, checking back to the original function. At -1, y is 5. Anyone get the y value for -√2/3? I think it's 5.08. All right.
You get the other one?
So the absolute maximum, we don't have one. Absolute minimum. that.
No, you just do.
Group 2 over 3.
What's that?
Please do the homework. Thanks.
Yeah, we not.